Thank you. We have like a minute for questions. Back row. Mike runner.
Thank you. Really interesting. I'm maybe going to ignore your last slide and ask a dumb question. Yesterday, we saw a bunch of talks of people making low D projections of the latent space of their networks for imaging and finding things like clusters. Did you have any success doing anything like that and finding that, particular pipeline glitches always seem to show up right in the same part of the latent space, and then weird QSOs always show up in another part in the spectra, analogous to what we saw with the images yesterday?
We didn't do that because I didn't see a need for it. Because that is imposing essentially a classification question onto something that doesn't actually have classification boundaries. And so I wasn't interested in it, but you could very well do it.
Yep. Okay.
Any other really quick question? Right. Next to the last person. Sorry.
Why AEs over VAEs?
If you explain me why those latent spaces should have a Gaussian distribution, I'll take your VAE, but it's a penalty during training that does basically damage, right? It's not just like, it's not a silent penalty. If you either want to have your latent space actually Gaussian, so that it can do forward sampling and likelihood evaluations fast, then you have to really impose a hard KL penalty. If you do that, you might do significant damage to the structure that might emerge, or different structures that might be beneficial to your task. We actually imposed a different relation and kind of an extra loss function that Jan invented in order to make this latent space more interpretable. Try this with a VAE and you can't.
Thank you.
And then last question in the back here.
So for your first, your spender model, I wonder, what's the minimum sample size? Because in galaxy spectra, there's lots of galaxy spectra, but like supernova spectra, not so many.
I don't have a good answer for you, but what we found is that the main properties of the galaxy spectrum is actually relatively stable, and it doesn't require a large number. The SDSS galaxy sample has something like, I'm going to say 500,000 or somewhere thereabout. But I'm pretty confident that if you try to do this with 50,000, you would find primary effects already being in place. It just won't be as expressive.
Thanks.